Hello viewers, in today's class we are once again going to solve one important conceptual problem from definite integrals, right? And here our integrand is a greatest integer function, right? So we have here the integral from pi by 4 to pi by 2 and greatest integer of cosec x, right? So let us call this integral as I, right? Okay, so now here we are going to solve this integral by the method of substitution, right? And here we'll take t is equal to cosec x, right? So we'll substitute t is equal to cosec x, and therefore dt over dx is equal to minus cosec x and cot x, right? So what we have done here, we have assumed this function, that is the function which is inside the greatest integer sign, that is cosec x is equal to t, and the derivative of cosec x is minus cosec x cot x, right? Okay, so now here cosec x is t, so we can write here minus t cot x, right? And now here to express cot x in terms of t, we'll use an important identity from trigonometry, right? Now we know that 1 plus cot square x is equal to cosec square x, right? And here 1 plus cot square x is equal to t square, because cosec x is equal to t. So cot square x can be written as t square minus 1, and cot x is equal to square root of t square minus 1, right? So here we'll take minus t, and for cot x we can write square root of t square minus 1, right? So dt over dx is equal to minus t and square root of t square minus 1. So therefore dx can be written as minus dt over t times, here we have square root of t square minus 1, right? So now this dx can be replaced by this expression, right? Okay, now here we see that the limits of integration are from pi by 4 to pi by 2. It implies that we have to change the limits accordingly, right? So when x is pi by 4, then obviously the value of t is cosec pi by 4, and the value of cosec pi by 4 is square root of 2, right? And when x is pi by 2, then we have t is equal to cosec x, here we'll have pi by 2, right? And cosec pi by 2 is 1. So now this integral I can be written in terms of t as here when x is pi by 4, t is square root of 2, and here we have 1, and here we have greatest integer t, and for dx we have minus dt over t times square root of t square minus 1, right? So now we can take this negative sign outside, so we have minus, or we can also do one thing here, we can interchange the limits, right? So now this negative sign can be removed by interchanging the limits. So we have here 1, here we have root 2, and we have greatest integer t dt, and in the denominator we have t and square root of t square minus 1, right? So now let us look at the limits of integration. So here we have 1, and here we have a square root of 2, right? And here we have 2. Now here we see that t varies from 1 to square root of 2, and square root of 2, it lies between the integers 1 and 2, right? And the approximate value of square root of 2 is 1.414, right? So here we have 1.414, and this t lies between 1 and square root of 2, right? So our t, it lies between 1 and square root of 2, which can be written like this, that is t lies between 1 and square root of 2. And any value of t which lies between 1 and square root of 2, the greatest integer of that value of t is always equal to 1, right? For example, if we take say t is equal to 1.2, right? And 1.2, it lies somewhere here, right? Here 1.2 lies, and this 1.2, obviously it lies between 1 and square root of 2. So therefore the greatest integer of 1.2 is 1, right? And similarly we can explain other values also. So now this value of greatest integer t can be replaced by 1. So I is now equal to 1 to square root of 2, and here we have, for this we have 1, and here we have t and square root of t square minus 1 dt, right? So now viewers, from integration we know the formula that dx over x square root of x square minus 1 is always equal to sec inverse x, right? So we have this result, and here we see that our integrand is similar to this one, right? So here we have the variable t, and here we have the variable x, right? So the integrand is similar to this one. So now the integral of 1 over t times square root of t square minus 1 can be written as sec inverse t, right? So here we have sec inverse t, and the limits of integration are from 1 to square root of 2, right? And now we can substitute the limits and we'll take the difference. So we have sec inverse square root of 2 minus sec inverse of 1, right? And secant inverse root 2 is simply pi by 4, right? And secant inverse 1 is simply 0, and we have pi over 4, right? Because we know that sec pi by 4 is equal to root 2, and sec of 0 is equal to 1, right? So from here we have pi by 4 is equal to sec inverse square root of 2, and from here we have 0 is equal to sec inverse 1, right? So we have pi by 4 minus 0 is equal to pi by 4, right? So viewers, the value of this integral is equal to pi over 4.